Have you ever finished making a web app and thought, wow, this looks great, and then you're curious how it would look on a mobile screen and yeah, it looks like this? If yes, this video is for you. In this video, I'm going to show you exactly how you can use Tailwind to write CSS that works on desktop, mobile screens, tablets, and every other possible screen. In this video, I'm assuming you have a basic understanding of what Tailwind is and how you can use it, at least at a very basic level. Tailwind has an entire page on his website that is dedicated towards creating responsive design, which is what we mean when we talk about styling that works on all types of screen sizes, from desktop to mobile to everything in between. The way that responsive design works in Tailwind is through what we call breakpoints. There are only 5 breakpoints that we need to learn about. There's small, medium, large, XL, and 2XL, as you can see by this table right here. A breakpoint is simply a predefined width measured in pixels. As you can see, small is 640, medium is 768, and so forth. The reason why these breakpoints are important is because in Tailwind we can use these prefixes and we can put them before any possible styling attribute to only apply for that breakpoint. As you can see here at the top of the screen, we do it by specifying the breakpoint we're wanting to use, then a colon, and then whatever styling utility that we want. One very important note here. This breakpoint represents a minimum, not a maximum. For example, medium is 768 pixels. That means that everything 768 and higher classifies as a medium screen. If I had a page, for example, that was 1500 pixels wide, that screen would meet the minimum requirements for small, medium, large, and XL, but not 2XL because it's below the minimum. If multiple breakpoints are mentioned, like up here, we will default to the breakpoint that it is closest to. In our 1500 example, that would be the XL breakpoint. I could read you this page all day, but just so you understand how this works better, let me actually show you how this works in real time. I have my React on the left with the corresponding web app on the right. I have the web app open with Chrome DevTools so I can adjust the screen size as I need to. As you can see, it just says this is a course for Tailwind, and I've given some super basic styling here on the left-hand side. Let's take what we just learned about breakpoints and apply it to the Tailwind on this page. You can see I have a property here that says text 5XL, which affects the size of our text on the page. If I add the prefix LG before it with a colon, I want you to watch what happens on this page. I need you to pay very close attention to the number at the top of this page right here. This is the width of the window that I'm on. If I begin to shrink this page, the width will then decrease. Notice how once we get to a certain point, the text shrinks. What point does it shrink at? Well, if we watch the pixel count here in the top, it looks like it shrinks right around 1024 pixels. Well, why is this? Because 1024 is the breakpoint for the LG prefix. And we explicitly said we wanted it to be 5XL when the screen size is large or higher. Which then means if we reach a size that is then below large, it just defaults to the normal text size, which is much smaller. Let's go ahead and delete this responsive prefix here, and let's add another background color. So right where we're doing the background red 600, I'm going to add another one that says background blue 600. But let's say we only want this background color to apply on screens that are medium or larger. So before this, I'm going to add the medium prefix, which is just MD with a colon. And if I go ahead and save it, we are below the medium breakpoint. Medium breakpoint again is 768. We are currently at 730, so we've not yet applied the blue yet. However, if we go past the 768 breakpoint, now the background color turns to blue. If I go back down and dip below the medium breakpoint, we turn back to red. What I'm trying to show you here is that we can have 2 styling attributes that reference the exact same thing. In our example, we have 2 attributes that both reference the background color of this div right here. But as long as you have one of them with a responsive prefix, in our case the blue, like MD for medium, it works just fine. The one with the prefix will apply at screens at or above the breakpoint. Anything else is going to default to the attribute without the prefix. So anytime the screen width is below the minimum of 768, it's going to be a red background. As soon as we hit that 768 minimum, anything at that minimum or above will be blue. Now you might be thinking, okay, that's cool and all, but that's just the color, and I want to make my design actually responsive. Arguably, one of the most important aspects of responsive design is shrinking flexboxes or grids into more narrow columns to fit on a mobile screen. So here's a simple page on it that just has 3 card components that I made with some random text in them. As you can see, the only styling that I have here in this main div is just making it a flexbox and giving it the property of flexRow so that it displays in a row format. Let's say in this example, I only want it to be a row if the screen size is medium or higher. If it's below that, I want it to be a column. The way that we can do that is by adding a flex call in here to be the default, And then in front of the flex row, let's add the MD prefix. So that flex row only applies if the size is medium or larger. If I save this now, and I go ahead and go over here, and I adjust the size of the page, notice once we pass 768 on the width, we suddenly go to a column format. So we go from being a row to being a column. Like I just said a moment ago, in Tailwind, if there is no prefix behind something like flex call, that becomes the default. If there is a prefix that is not the default, it will only apply at that breakpoint or higher. So once we get to 768 or higher, we turn back into a row. This is going to be one of the primary things you see when working with desktop versus mobile web apps, converting rows into columns or vice versa. This is because mobile screens are obviously much more narrow, meaning you're almost always going to have columns instead of rows in order to maximize space without having to cram everything together. The other way you may see this done is with grids. In this example here, I have a grid layout that is 4 columns wide, and I filled it with 12 grid cards that I just made as my own components. If I go over here and I start to shrink this window, notice how these cards at the edge of the grid start to get cut off right about here. Even if I tried to adjust the width with this width fit to avoid them getting cut off, they would still start getting smashed in at a certain point, as you can see here. Text is flowing out of the boxes are getting all crammed in. A clever way that we can avoid this with grids is to change the number of columns based on how wide the screen is. For example, let's make grid calls 4 right here only apply to screens that are larger or above. So we'll say LG like this, and then for every other type of screen, we're going to say that there are going to be 3 columns. If I go ahead and try and adjust it now, we know the large breakpoint is at 1024. As soon as we hit 1024 right here, notice how it goes to 3 columns instead of 4. But then if we keep going, notice we have the exact same problem again. It starts getting cut off. So we can actually add multiple styles here for multiple screen sizes. We'll make this 3-column layout only apply with medium and higher screens. So we'll say medium like this. And then for every other type of screen, let's just go ahead and give a grid calls of 2. And now that we've saved it, you can see there are 2 columns because we are below both the LG and the medium breakpoint. But if we go back to the medium breakpoint, now it's 3. If we go back to the large breakpoint, now it is 4. I could, if I wanted to, make a small breakpoint that says it is 2, and then when it's below that, it's 1. But I think now you probably get the picture of what I'm trying to show you. If we ever have 2 or more references to the same attribute that both have prefixes, in our example, the number of grid columns, we have both a large breakpoint and a medium breakpoint, we will default to the highest available one. So let's say our screen size is maxed out here. As you can see at the top here, that is 1418 pixels in width. Well, 1418 is closer to the large breakpoint than it is to the medium breakpoint. Therefore, we default to a 4-column layout. If we dip below the large breakpoint, we are now below the minimum for it, but our next closest available one is medium, which is a 3-column layout. You get the picture. One thing you might have noticed is that we're kind of working backwards here. We're taking larger formats like the grid column of 4 and having to add prefixes to them so that we can create defaults that default to a smaller mobile screen size. The reason this is the case is because Tailwind takes a mobile-first approach, meaning it's styled in such a way that it makes more sense to create a mobile layout first, and then from there add properties with prefixes that then work with larger screens. Both grids and flexboxes are going to be 2 of the most useful things to know how to handle in responsive design, but there's a lot more to it than just that. Remember that every single property can have a responsive design prefix. So I could go onto Tailwind's site and I could find literally any possible attribute here. For example, I could just go here, I could go to any of these align or justifies, and any one of these things can have a responsive prefix in front of it. If it exists in Tailwind, it can have a prefix. For the sake of efficiency, I'm not going to show you how every single one of these things works with the prefix in front of it, because they all work in the exact same way. But what I will do now is jump over to an actual web app so you can see responsive design in action. The site in question is the one I showed you right at the beginning of the video. I have it in a desktop layout right here, and even though it's shrunk down a little bit, it looks great. There's some really nice charts, some good spacing between them, nice little nav bar here on the side, and everything is looking just how it should. If we go ahead and shrink it, however, it suddenly looks hideous. Let's apply what we just learned with responsive design to fix this page. If we look at the file organization of this project, it looks like a ton of stuff is going on here, but most of these files we don't need to even worry about. The page you're seeing here on the right of the screen is just this ecommerce.tsx file. We have one div at the top here that's rendering 4 of these card data stats components, which is just these 4 cards you see here in this very top row. And then we have a div at the very bottom here that is rendering 3 charts, which is these 3 charts right here, this map, which is the map of the US, and then we have this table right here it's being rendered, which is this table here that has the Google, Twitter, and GitHub logos. And then lastly, we have this chat box, which you can obviously see right here. Let's scroll back up on the app, and let's actually start with the div that contains the 4 card data stats components that we see right here. If you look at the class name for this div, you can see there's already a little bit of responsive design right here with this medium prefix to configure how big the gap is between each card. I have not messed with this, and we're not going to worry about it. However, let's focus on the fact that right now, our grid has 4 columns, as you can see right here on the right. The fact that we have 4 columns looks great on a desktop, but when we shrink the pages down, the 4 cards we're looking at are just super cramped. And that's because even when our screen is tiny, we still have the 4 columns. So it's trying to jam everything into these super narrow columns. One very easy way to fix this will be to make it so that whenever the screen is small, we only have 1 column, and the cards are just stacked above and below each other. Using what we learned earlier, especially with grids, we can do this just by writing right here. We will write grid calls 1. Oops, if I can write that right. Let's scroll over so you can see a little better. And then let's say we only want a 4-column layout if the screen is at or above, let's say an XL size. So we'll go ahead and save it here. And now if we shrink the page and it goes below XL, these will each turn into their own row essentially, because it's now a 1-column layout. And just remember that excluding a prefix from an attribute will make that the default. So that we're saying that a 1-column format is the default unless we are at or above the XL size, then we're going to go back to the 4-column layout. However, let's consider something real quick. Right when we hit the breakpoint of 1280 where XL is, notice how there's a ton of extra white space here on these cards. These cards probably don't need to be this big, and we should probably make them a little bit smaller or adjust our column layout. Let's fix this by adding another breakpoint. Let's say with screens that are medium size and up, so we'll do MD, we're going to say grid calls 2, and we'll go ahead and save it. Now, if we adjust the screen size, we start at max size. We have 4 columns. Once we dip below that and go to the medium breakpoint, we have 2 columns. And if we keep going beyond that, below the medium breakpoint, which is 768, then we will hit 1 column. This is exactly how you would use multiple breakpoints if you wanted a design to look responsive with more than 1 or 2 possible screen sizes. We have these cards looking pretty solid now, so let's move down to the bottom div of the page, the one where we are rendering these charts and these tables. As you can see here, we have a grid layout and the grid has 12 columns. However, all of the styling for these individual charts in terms of how many columns each of them span is within the actual component themselves. So we'll have to access the component code in order to make changes. However, real quick before we do that, let's take a quick look at this div right here, the one that has a column span of 8 that contains the table component. If we scroll down, we can see that that is just the table here that has the Google, Twitter, and GitHub logos. Because of this line that says column span 8, at every possible size, it will always span 8 columns. So that looks good when we have a page like this, but when we shrink the screen way down to, let's say, mobile size, and we look at it, this table right here looks super cramped and doesn't really give us much room to work with. An easy fix for this would be to make column span 12 the default because it is a 12-column layout, and have the column span of 8 only apply when the screen is XL or higher. So go ahead and save it, and you can see now it is basically in its own row by itself because the screen is too small and you want it to take up the entire width of the grid. Using column span is a really common thing to do when working with responsive design when it comes to grids, because you generally want to make sure on mobile screens, or at least on very small screens, that the width of each individual thing in the grid is usually the entire width of the grid itself. So we have a 12-column layout, and when it gets small, we want it to take up that entire width instead of just 8. Because when it takes up only 8/12 of the grid, it does look cramped. Now that we got that worked out, let's take a look at each of these charts here, starting with chart 1, which is this one right here, the total revenue and sales, and chart 2, which is this profit chart. Let's take a look at the source code for both of these charts here. If we go ahead and go to chart 1, and we scroll down to where we are displaying it, we can see if we go over here that it is taking up a total of 8 columns. And if we do the same thing and head over into chart 2, scroll down to the same spot and look over, we can see it is spanning 4 columns. which definitely checks out the way they display on this page because chart 1 is taking up the majority of the width and chart 2 has a much smaller portion of it. Once we shrink this page down to mobile size, they still have the exact same column spread, which looks extremely cramped and not good at all. Because you can kind of see the revenue chart a little bit, but you can't even see this profit chart at all. We have a very simple fix for this. In chart 2 here, let's go ahead and make column span 12 the default. And then column span 4 will only apply when we are XL or higher. And then we'll do a similar thing for chart 1. We'll go over here and we'll say the column span should be 12 when it is anything other than XL or higher. But if it's XL or higher, then we're fine with the 8 column layout. What this means is that if we're on small or mobile screens, is that chart 1 and chart 2 will both take up the entire width of the grid. Again, the grid is 12 columns wide, and we're making each one span 12 columns, so we're making it the entire width of the grid. Go ahead and save both these files, and you can see how the page changes. You can see now if we mess with the size of the page, that both of these charts are going to span the entire width of the grid up until the point we get to the breakpoint that is XL, which should be at 1280. And then suddenly they go back down to being their original format of 8 columns and 4 columns respectively. The next two things I want to look at is these two charts down here, this visitor analytics chart, which is chart 3 in the code, and this map here, which is just called map. If we look at the code for chart 3 and we scroll all the way down, you can see it spans 5 columns. If we look at the code for map here, we can see that it spans 7 columns. Let's keep it super simple and apply the exact same thing we did with the previous two charts. We will make the default column span to be the entire grid, which is 12 columns. Otherwise, splitting the column span will only happen at screen sizes of XL or higher. So I'll go ahead and save this file for map, and then we'll go into chart 3, and we'll do the exact same thing. We will say column span is going to be 12. However, when it's XL or higher, we are perfectly okay with doing a column span of 5. Go and save this, and they haven't changed yet because we are still above the XL breakpoint. But now if we go below the breakpoint, you can see they are now each in their own row. Looking back in our e-commerce dashboard component over here, we've fixed all the charts plus the map, and we have this table that we fixed here earlier. That is just this table right here. The only last thing we need to fix is this chat box that we have here at the bottom. Nothing too crazy. We'll apply the exact same thing we did with the other charts and tables. We will say that the default will be to column span 12, but then when it's XL or higher, it'll only be 4. Go ahead and save it, and now it takes up the entire width of the screen because we are below the XL breakpoint. Now that we've adjusted each of these components, let's take a look at the finished product of our dashboard. Starting at maximum width, everything looks good. And if we go ahead and start shrinking it down, you can see we will eventually pass the XL breakpoint, which is what most of our prefixes are. All of the charts are in their own rows instead of sharing rows, and these cards at the top go to a 2x2 layout. And if we keep going, eventually everything turns into a row here with essentially what is one big column for the whole page. Let's compare this page to what it was before. Yeah, that's a huge improvement. One last change to the site that I'm sure you're wondering about. You may have noticed that the side navigation menu on the left-hand side automatically shrinks down once we get below a certain point. Because of the space the side navigation menu takes up, this is one of the most common things you'll see when working with responsive design. A menu that shrinks down past a certain point and becomes toggleable through a button like this one right here. At the very beginning of the video, I showed you the sidebar stuck out like this, even on smaller screens, and I'll show you how we can work with that. The code for the sidebar is in this index file that I'm working in here within the sidebar folder. This entire sidebar is honestly a couple hundred lines of code, but in terms of responsiveness, we only really need to look at one line right up here at the very top with this class name. First off, let's look at what this conditional statement is doing. And again, this is just part of the class name still. Sidebar open is a boolean that is just true or false depending on whether the sidebar is open or not. If it is, we apply this translate x0, and if it's not, we apply this negative translate x full. Translate x0 means keep it exactly where it is. This negative translate x full means, for example, if our width was 200 pixels wide, this negative translate x full means move it back 200 pixels, or in other words, make it completely go away. The minus is really important and tells us it's going to go backwards. So what that means in practicality is on mobile screens when it is open, that means sidebar open right here is true, and translate x0 means keep it exactly where it is. So right now it's just sitting here. However, if it were to go false, we would move it back. Let's say this is 200 pixels wide for this whole thing, and it goes to false, it moves it back 200 pixels off the screen. If we scroll to the right and look over here, you can see we have some responsive design that says LG static and LG translate x0. This means if we're at the large breakpoint or above, which is 1024 here, then we just apply these things always, meaning it will remain static and it will remain in its original position. Otherwise, if it is below 1024, that is when we revert back to this conditional statement to check whether it should be open or closed. The only last thing we need to look at now for this sidebar is for the button on mobile screens that actually activates it, which is this button right here. And notice this button is the one that will change this sidebar open boolean to be either true or false. The button is only available on smaller screens because if you notice when we go to larger screens, the button disappears completely. If we scroll down and look at this block of code right here for this button is actually not for the one you're seeing on the main part of the dashboard, but it is the button that you see right here, this back arrow, that allows us to close the menu. And the reason why this back button appears on this screen, but not when you're on a larger screen like this, is because of two simple words. This right here, block and LG hidden. What actually ends up hiding it at larger screens is this LG hidden right here, because we're applying the hidden property whenever the screen is large. But you may be wondering, what is this block thing right here? Block and LG hidden are often used together for sidebar buttons. These are both part of the display property with Tailwind, so it can't both be active at the same time. And I can show you that if I delete the LG here, it'll give me a little error here saying that they're basically working with the same CSS properties. All that it's saying is that if the screen is larger or bigger, it'll hide the button, and if it's smaller than that, it turns into a block element, which basically just puts it on its own line and fills the entire width of its parent container. Block is only one type of display, so when you're hiding things on bigger pages, you might see LG hidden in conjunction with something like flex, or even something like table or grid, but just having LG hidden in conjunction with another display type is basically a way to do hidden versus not hidden. Now that we've taken a look at the sidebar and fixed all the elements on this dashboard page, we're left with a page that looks great on screens of any shape and size. If there's one takeaway from this video, remember this. Responsive design is super important for one huge reason. Over half the traffic on the entire internet comes from mobile devices. If you just build an app for desktop only, over half the people in the world accessing the internet are going to have a problem accessing your site. It's going to look unusable. And with that, we're going to go ahead and end this video here. Now that you've watched it, you should have a better understanding of how we can make mobile pages look great on all screen sizes using Tailwind. Take care everyone, and I'll see you in the next video.